Hi everyone, welcome to today's SilverlightShow webinar. My name is Alex. I'm pleased to introduce today Peter Kuhn, who will deliver his second webinar for SilverlightShow. The topic of today's live session is networking with sockets in Windows Phone. This session will take approximately 60 minutes, and after that we'll have a short 10-minute Q&A session. Before I give the word to Peter, remember that SilverlightShow and Pack Publishing are giving away 3 Windows Phone 7 cookbooks to 3 of you who will tweet this webinar using hashtag webinar SilverlightShow, etc., etc. Peter, can we begin?
Yes, of course. Thank you very much for this kind introduction. I'm glad to be here. Okay, let me just show and share my screen. Okay, I hope you can all see my screen now. Okay. Oops. Looks good so far. It's also nice to see that a lot of people are interested in the topic, even though it's a bit more technical and a bit more complex than other topics I do trainings and webinars on. So let's start with a quick introduction about me. My name is Peter Kuhn, like Alex already told you. I'm known as Mr. Goodcat in the community, and I'm 34 years old. I work as a trainer and consultant for .NET, Silverlight, and Windows Phone 7. And over the last years, I have earned several Microsoft Certified Professional Developer certificates, like for developing enterprise applications, web applications, and for Silverlight and Windows Phone 7. I have earned the Microsoft Community Contributor Award in 2011 for my work on the Silverlight forums. And you can find more information about my trainings on goodcattrainings.net. And also my blog address is listed here. And also feel free to contact me on Twitter. That's always a good starting point if you want to draw my attention to something, or if you want to start contacting me. Okay, so let's take a look at today's agenda quickly. We will talk about networking on Windows Phone 7 and what has changed in the Mango release compared to the RTM version of Windows Phone. In particular, of course, the socket programming options that have been added, and we will talk about why it's why you should and for what you can use sockets, as well as the differences between the different options you have using the protocols TCP and UDP. We will have a live coding session where we built a small client application from scratch using UDP sockets. And we will also take a deeper look at the obstacles and possible pitfalls when you develop socket applications in various stages of your development process, and hopefully quickly have time to take a look at how you can work around some of these issues. And in the end, I will give you a small list of additional resources you can take a look at, and we will also have the Q&A session like Alex already mentioned in the beginning. Okay, so when we take a look at networking in the RTM version of Windows Phone, then it's apparent that networking per se already is very important for the phone because even though we are dealing with a mobile device, people expect that they have access to an integration with, for example, cloud-based services, that they can synchronize their data across multiple devices, that they can access all kinds of remote resources. So we already have a rich set of networking options on Windows Phone in the RTM release, in particular, like I said, accessing web services and making use of remote HTTP resources. both by using a higher level component, which is the web client, and a bit more lower level approach using HTTP classes. What has changed in the Mango release is that a fourth component, a fourth area was added to the developing options, and that is sockets. And before we take a look at what sockets can be used for and why for what you can use sockets in your own applications, I want to go ahead and take a look at the currently available features for networking on the phone based on the complexity of the technologies involved. Because we can categorize and order the available options based on their level of complexity from high level to low level. We have the web services as the highest level feature of networking on Windows Phone. I list operation-based web services here, but this applies to all kinds of web services that you ideally use some auto-generated proxy types that give you the option to work with your web services using strong typed objects, and all the operations and all the objects you use for your web services communication are domain specific or application specific, which means you are working with things like web services methods that are named get all orders for customer with ID something. So this hides away all the networking details that obviously happen in the background and allows you to transparently work with a remote resource without having to take care of the underlying networking things at all. Then we have the web client class, which is made to interact with remote resources using HTTP as a protocol. It becomes a bit more low level using this class because now even the names reflect some of the networking nature involved with this class. You are dealing with methods named download and upload things and strings. But it still is easy and simple to work with this class because it simplifies the underlying networking mechanisms enough so you can just invoke a method that pulls a remote resource and simply hook up like the completed event to get the result of the operation. And you still don't have to deal with any of the low-level networking details. If you want to have more control over the HTTP communication, you can use the HTTP classes, in particular HTTP web request and response, that give you more control over details like cookie handling or certain headers. But this control comes at a cost. You have to manually deal with the HTTP workflow and process, like the request and response process, and you have to implement that in multiple steps and deal with this manually. And now the new option, sockets programming, that has been added in the Mango release, is at the moment the lowest possible level of networking on the phone. It is, of course, not the lowest possible level of networking at all. There are always lower levels. Sockets, and in particular TCP and UDP programming, is located, if you're familiar with that, on the OSI level 4, I think, yeah. So there's always a lower level below that, for example, manipulating IP packets manually. But sockets at the moment is the lowest possible level of networking on the phone. The special thing about sockets is that these are not bound to a specific protocol like HTTP. which is used by all the other classes, you have full control about what data is sent across the wire, always within the limitations and bounds of TCP and UDP, but you have full control about what is sent and how the network communication is handled. So let's go ahead and take a look at what sockets can be used for and why you should be interested in sockets and what you can do with sockets in your own application. Like I said, all the previously existing features builds upon HTTP as the protocol used for communication. But there are a whole lot of other protocols built on top of technologies like TCP and UDP. Some of them listed here, but there's a whole lot more of protocols. For example, what's listed here is file transfer protocol, various email protocols used to fetch and send emails, IMAP and SNTP. We have chat protocols for IRC chat, for example. IRC protocol, for example. We have Telnet as a remote logging and remote control protocol. We have the network time protocol to synchronize clocks across networks. We have protocols like SNTP, which is a management protocol for network components. And each of those were not possible to use from the phone before the Mango release, because you had no way of implementing these protocols to be used from your Windows Phone application. In some cases, what was possible before is that you could create proxy web services, for example, and let your Windows Phone application talk to your proxy web service to perform the operations that are based on these alternate protocols for your Windows Phone application. This is problematic in various ways. For example, of course, this means that all clients will make use of your central web service. So this can become a problem if a lot of clients want to use the feature at the same time, if the feature is computational costly, or if a lot of bandwidth, for example, is required. Imagine you create a proxy web service for an FTP access, and all the clients of that use your Windows Phone application upload and download files through your single and central proxy web service. That can become a bandwidth problem easily. And in other cases, it wasn't even possible to circumvent these limitations using proxies or web services. For example, if you think about the management protocol, then you often what you want to do is you want to connect to networking components that are located in a local area network. So a proxy service wouldn't help with that at all, because that external service would have no access to the local components in your local network that are usually protected by firewalls and network address translation and things like that. So socket programming opens this field and makes it possible for you to use all these features in your Windows Phone applications if you want to. Of course, you need to go through the efforts of either implementing these protocols in your application, or to find a third-party library that already does that, or port an existing library that's available for other platforms like Silverlight or .NET for the desktop back to or down to Windows Phone to make use of that. But in theory, it's possible to use all these protocols with some minor limitations I will talk about later. And of course, you also have the possibility to create your own application protocols. For example, you can use web services for almost all cases where you want to do communication, or you can base your communication on the HTTP features. But that often means that you're not using the perfect tool for the job, because imagine you need to send small amounts of data, you need to send them in a real-time manner, then it will be very problematic using web services, for example, using a SOAP-based web service that has then a lot of overhead and a lot of wastes a lot of bandwidth compared to if you would use a network connection that is optimized for your particular needs and that can save network bandwidth and traffic, which often is very expensive for users on the mobile platform. And of course, the last point here also is very important: optimization of performance. In particular, if you want to create this real-time or almost real-time experience, then web services or HTTP is not very suitable. Protocols like UDP are perfect for that and are made with things like these in mind. So now that we have sockets, you can create exactly these experiences and have things like multiplayer gaming, which often makes use of UDP, or media streaming, or chat clients with arbitrary protocols and features that would be difficult to implement using the existing features in the RTM release. Okay. Once you have decided that you want to work with sockets, you have to choose between TCP and UDP. So I want to quickly talk about the similarities and differences between both, to give you an idea and a bit of a better feeling of what you should base your decisions on when you choose between both. TCP is a connection-oriented protocol, which means you have to explicitly connect to a remote computer or to a remote server on the network before you can start communicating. And in the same way, you also have to or should close the connection when you're done communicating. UDP, on the other hand, is a connectionless protocol, stateless also, which is implied, which means you can start sending to a remote address right away without connecting to this address explicitly. There doesn't even have to be a computer or a server at the other end, behind the address you're sending to. There's no mechanism that makes sure that someone's actually there and receives the data you're sending. And in the same way, you also don't have to close any connections. You simply stop sending or stop receiving, and you're done. TCP uses this connection-oriented approach to guarantee a really high level of reliability. TCP guarantees you that your data is transmitted, that there are no transmission errors. It guarantees that the messages and the data you transmitted is received as you send it. And it also guarantees that the receiving side receives all data in the correct order. UDP, on the other hand, is optimized for performance, like I said, for scenarios like real-time communication, and it does everything to reduce the latency as much as possible, which means it doesn't care if packets are lost on the way. TCP, for example, requests missing packets from the sender if it detects that a packet was lost on the way. And because it also ensures that the receiving side receives all data in the correct order, this means that it introduces some amount of latency until the missing piece has been received, so the receiver can consume all the data in the correct order. And UDP does not have any of these mechanisms. It simply will skip over lost packets. There's even no mechanism to detect that packets are lost unless you build one yourself. So this ensures that the receiving side can consume the packets as fast as they arrive, and this is the basis for real-time communication scenarios. TCP also has a lot of other built-in nice features, for example, flow control or congestion control, which ensures, for example, that if the receiving side of the connection is not able to consume the data as fast as you're trying to send, then it will go ahead and throttle the data rate and make sure that the receiver is not flooded with data, things like that. And all of these also are not part of UDP. UDP simply, with UDP, it's your responsibility to make sure that you're not flooding a receiver. For example, let's say you're sending data to a computing device that has not very much computing power, or a weak processor, a weak CPU, and it's not able to keep up with the amount of data you send to it, then TCP will try to handle that and UDP won't. With UDP, you have the responsibility to do that yourself. And the last point I want to talk about, and that's a very important one, especially if you're not experienced with TCP and UDP programming, is that in with TCP, you are working with a stream of data. It's your responsibility to take that data you receive in a TCP connection, a TCP communication, and extract the original messages back from that stream of data. Let me give you an example. For example, if you have two messages you want to send to a remote server using TCP, then these two sending operations not necessarily mean that on the receiving side there will be two receiving operations. TCP has all sorts of optimizations built in, which, for example, try to avoid overall use of the network, which try to avoid waste of network bandwidth. So it tries, for example, to combine multiple small pieces of data into one big network message to make optimal use of the network connection. And that can lead to the situation that on the receiving side, you receive a chunk of data that contains several application messages at once. It can even lead to the situation that TCP decides to chop your application message into several pieces and send them in several pieces. And on the receiving side, you are then in the situation that you all of a sudden have half a message received and there's no further data. You have to wait a bit more until the other half of the message is received, and then you have to reassemble the original message yourself and continue with processing the application data contained. UDP, on the other hand, in that case is much simpler to handle because it uses datagrams that are sent out as soon as you tell it that data should be sent, and they are also received individually, so you don't have to care about combined and split up datagrams. But of course, this also means that you have to, for example, take care about and consider the amount of network packets you're using, and that you have to, for example, consider the size limitations of datagrams manually and make sure that you're split up your data manually if the size of the data exceeds the available maximum size of datagrams. Okay, so to sum it up, if you want to create something that uses near or next to real-time communication, then you would probably go with UDP. If you have no problem with individual packets that may be lost, packets that may be distorted or damaged, or packets that may even be received out of order in some rare cases. This all sounds very dramatic. It happens a lot less in praxis than you would think. especially with wired connections, but it does happen, and you always have to be prepared for lost data and work around this, or have a situation where lost data doesn't matter. And TCP, on the other hand, has all these benefits of reliability. So if you want to create an application that needs data to be transmitted reliable, then you would, of course, go with using TCP. In the following, we will see how sockets are used in code, and you can see that both types of sockets share the same classes and share the same logic and mechanism. So switching between both is not very difficult. The difficulty often is to adjust the application side, like I said, for example, with reassembling original application messages when you're using TCP. Okay, so let's go to the let's proceed with a live coding sample. What I want to do is I want to create a client for the network time protocol that goes out and fetches the time that is provided by a time server on the internet. And to give you an idea what you need things like these for, a quick example of what this is used for in practice. For example, if you have a server side, a service running somewhere, and you want to receive data from multiple clients, multiple Windows Phone clients in this case, that are distributed all over the world, and you want to compare or make the data you receive from these clients comparable in terms of the timestamp that data has been produced. Think of games, for example, where you want to determine something like collisions, for example, in a central service. Then you need to not only analyze if in the terms of a game, for example, two players are in the same place, but you also need to consider if these two players are in the same place at the same time, because one of the players may be much further away from your server than the other one, or may have a much worse network connection, so the message sent from the client to your server takes a lot longer to be received from your server than the other one. And even if the messages arrive at the same time on your server, they may in fact be have been sent at different timestamps. So that is the case where you want to ensure that the data collected on the clients can be treated and can be compared and is somewhat synchronized in terms of the timestamps they are created at. And to do that, what you can do is you can fetch the time from an internet time server, which allows you to get a very accurate time information on the client, and to produce timestamps that you can then use, for example, in your server to compare data received from multiple clients. So what I'm going to do is I will create a new project and call that SNTP sample. Okay. And since this is about sockets programming, I will not go into the details of the NTP protocol. What I will do is I'm working on another open source project that will contain various helper classes with networking stuff for Windows Phone, and I will add the NTP implementation to that open source project, and keep an eye on my blog or my Twitter to get notified about when I upload this particular code. But for this sample, I will not go into the details of creating the protocol implementation of NTP, but I will focus on how to use sockets on the phone. Okay, so let's set some values here. What I will do is I will have a very simple UI that simply uses some text blocks to show the current time on the phone, and another one that shows the corrected time that we received from the server, and a button that allows us to invoke the actual network call that goes out to the server. Okay, so these are the elements. We have a text block for the local time, a text blocks for the corrected time, and the button that will fetch the time from the server. Okay. Okay, and one more thing, what I will do is I will use a dispatcher timer here that will be used to update the time display once a second. Let's go ahead and initialize this here. Set this to a time span of 1 second. Hook the tick event. And we will actually start it. And then we will simply fetch the current date time and use one of the text blocks we have created to display the current date time. To string, I will use a format of U here. Okay, and in this button click event handler, we will go ahead and use the SNTP client that we are going to create now. SNTP client. I will create a new class for that, and this will be where we will implement all the socket logic. First, we need some constants that we use, for example, the time server. Of course, you would make this configurable in a real-world application, but for now I will go ahead and use a fixed value. And that is a server located here in Germany that provides time synchronized with an atomic clock. So this should give us a very accurate time. And the port used for communication using the NTP protocol is 123. Okay, so the central classes involved in socket programming are, of course, socket, which is the class that performs all the operations in communication, for example, sending and receiving data, and in case of connection-based protocols like TCP, also the connecting to a remote server. And the other one, and that's interesting, is socket async event args. That is a event args class that represents one single ongoing operation. This way of working with sockets has been changed during the during the evolution of the .NET framework. We have different ways of using sockets in the desktop version of the .NET framework. We also have the old or the existing asynchronous programming model. But this way of using socket and socket async event args was added and has been added to optimize the socket's performance using something that is called I/O completion ports. I won't go into the details of that, but this way of the only way of working with sockets on the phone is a very performant way to do that, and it's perfectly possible to use the same way to work with sockets on the full version of the .NET framework. So, for example, reusing code or using similar code on both platforms is something that's not very difficult to achieve. And if you have worked with the desktop version of the .NET framework, then this should be really easy for you to follow and to use. Okay, something's wrong here. I don't know what's wrong here at the moment. Oh, I accidentally changed the name. Page name instead of the text. Okay. So obviously what we need is we need a public method that allows us to start the operation to get the time from the server. So let's make that method and name it getTimeAsync, because all networking is async on the phone and for Silverlight. A word of caution about the MSDN samples that you can find about socket programming on the phone. I find it a bit unfortunate that all the samples make use of wait events to turn the asynchronous networking operations of sockets into synchronous ones, effectively blocking the UI thread. I don't know what the decision was to make the samples in that way, because I personally very much dislike the idea of blocking a UI thread, especially with operations like networking, and even more especially on platforms like the Windows Phone, like mobile platforms, where you have often very unreliable networking connections that can go away any second if the user has a bad connection, and where the user experience is very, very important. For example, to provide a snappy user interface, to be able to react to touch input and things like that. So I don't know who decided to make these samples synchronous and block the UI thread for that. I would not recommend following any of these samples that are available in the documentation at the moment. Okay, the first thing to do is to create a new socket, and there you have the option to choose the address family you want to use. The only one supported is IP version 4. At the moment, Windows Phone does not support IP version 6. Then you have to choose the socket type, which is either stream or datagram, and those imply the type of protocol you want to use, because streaming implies TCP and datagrams are used by UDP. And the network time protocol uses UDP. So we create a UDP socket here, and we also create the socket event args. And the way to use them is that you configure the socket event arguments with all parameters and all data that you want to use in a operation. And then you pass on these event args to the socket to perform the actual operation. And that allows you to, for example, handle multiple parallel operations with one socket and multiple event args. And this also allows you to reuse, for example, these event args for multiple operations that you do sequentially. Something that is not possible with the other approaches used on the desktop version of .NET, where you work with async results. It's not possible to reuse them or to make use of them in the same way. The socket event args have a completed event that you can consume whenever an operation has finished. Completed. And the way we need to interact with NTP in this case is that we set the remote point, which is the server we want to contact, and then send the actual data. Okay, so the like I said, all the configuration for an operation is done with the event args. So we set the remote endpoint here, and we can use a DNS endpoint that allows us to pass in a host name and a port. Time server port, not timer. And we then need to build the data we want to send. This is what I talked about. This is the NTP specific part where you create the data that you want to send to the server. This data depends, the format of this data depends on the protocol that is used, and NTP has a certain format that you need to provide to the server. And the data, of course, needs to be converted to a raw byte array that can be then sent across the network. And the way we do that is we specify what data should be sent using the setBuffer method of the event args. So let's provide this, which will be a byte array. And you can specify the offset and count if you use one huge buffer that contains multiple messages, or that is a circular buffer, or things like that. Then you can specify offsets and the length to use here. What I will do is that I can use these methods. I will go ahead and paste in the code required for the NTP protocol here. Let me switch to this file I have over here. And what this does is, for example, it converts the timestamps expected by a time server back to .NET datetime values, and it converts the datetime values of .NET to something that the server can understand, because they use a very unique representation of timestamps. Okay, so now we have this create request method that returns a byte array, and we pass that on to the socket event args to be used in the socket operation. And now all we need to do is we need to tell the socket that we want to send some data, and all the configuration information for this send operation is contained in the socket event args. So that's basically how you send data. This send to method is used for connectionless protocols like UDP, and there's also a send async method that can be used for connection-oriented protocols, in particular TCP. You can, by the way, also use the send to method with TCP, but you cannot use the send async method with UDP. So for UDP, we have to use the send to async method. There's a small twist in this, because this returns a Boolean, and this describes whether the operation has been queued for asynchronous processing or whether it completed synchronously. I have not seen this happen in practice, but if it does, then the completed event of the socket event args will not be raised. If the operation completed synchronously, then this event handler will not be invoked, and then it's your responsibility to continue here with whatever you want to do after the sending. And the pattern you usually would use is to invoke this event handler manually and pass in the socket as sender and the socket event args as arguments. So that's the pattern. If the operation is executed asynchronously, then the completed event handler will be invoked, where you can continue your work. And if it finishes synchronously, then we simply manually invoke this event handler. And what we do here is, the usual thing to do here is, first of all, you go ahead and check for any errors. So you make sure that you are receiving a socket error of success here, which indicates that no error happened. And if some errors happen, then you want to do things like clean up your sockets, it's important to always clean up the sockets and socket event arcs to free resources that are allocated behind the scenes for you. And we also want to notify the user about something bad that happens, maybe pass on the socket error here. And in case no error happened, you can proceed with processing this data. And you can do that by switching a property of the event arcs that is named last operation. And that allows you to determine what was the last performed operation of the socket and the socket event arcs. And you can see that we have this send to operation that we invoked up here, available here. And now we can create the sequence of logic that we want to perform, which means in case the send to operation was successful, we will go ahead and reuse the existing socket event arcs. This is the part that is new. And say, okay, now we want to reuse these event arcs to perform a receive operation. Because now we send the time request to the server, and now we want to receive the answer from the server. Okay, so go ahead and start a receive from async operation, reusing the same socket event arcs. And I just changed the endpoint used here to enable receiving data. Receiving data is not possible using a DNS endpoint. You have to use an IP endpoint, but you can use any IP address to receive UDP data from any remote address and any remote server. And in the same way, if this operation has completed synchronously, we simply go ahead and invoke the event handler, because the completed event will not be raised automatically here. And then we can go ahead, the second time this event handler is executed is probably when we when the receive from operation we have started here has finished. And what we will do now is we will go ahead and say we have our calculate clock offset method here that calculates that converts back the values received from the server to something .NET understands. And we will then need to notify the outside world that we have received this data. So we will raise an own event that passes on this computed clock offset. And I will paste in these methods that invoke an event that we have not yet defined in our class. So that's simply an event that can be consumed to get notified about the outcome of the server request. And we also need the event arguments here. And there seems to be no errors. And in the cleanup method, that's something I wanted to show you. You have to free the resources that were allocated by the event arcs. So you can dispose the event arcs. And you can also go ahead and check the socket. If we have socket, then also call dispose or close, so wrapper around the dispose method here to close that. We don't have a connection, but we call close anyway. It doesn't hurt to free any resources from this socket. So, okay, so once again, the logic is we start sending out a request to the server. hook the completed event of the socket event args to get notified when the operation has finished. And when it has finished, we check if what we need to do next, and if we need to use this, if we have sent the request successfully to the server, then we start a receive operation using the same socket event args, causing the same completed event handler to be invoked. And the second time we come in here and the receive from operation has finished successfully, then we can use the data we have received from the server, which by the way is contained in the buffer of the event args, and extract the time information and pass it on to whoever called us, or whoever is using us, whoever is using is consuming our own completed event here. And I can now go ahead and consume this in the main page I have here. I simply go ahead and create a SNTP client. And in the button click event handler, I start the get time async operation. I of course need to hook the completed event here. And in that completed event, I need to go ahead and marshal back what I received and what I want to do to the UI thread, because all this is performed on a thread from the thread pool, which is the normal thing with socket programming. So I need to go ahead and make sure that I marshal this back to the UI thread. And once I am in the UI thread, I can check for any errors that have occurred, and if no errors have occurred, then I can store what has been calculated in this local variable, in this local field of my class that I also have to define up here. And the last thing to do is in the timer tick event that we have created in the beginning, I now want to check if I already have received an offset from a server, and then I want to display the corrected time, which is simply the current time reported by the phone, corrected by the offset value determined by the time server. So let's go ahead and compile that, and hopefully we can see that this works. Let me just get the emulator. And what you can see is that the local time is reported here. And to demonstrate that this is actually working, I will go ahead and change the time of the emulator to something different. Go back to the application. So it now reports 8:50 p.m., which reminds me that I should finish soon. And if I fetch time now, you can see that the call to the server is made, and the corrected time now says 7:53, which should be a very, very accurate time. The accuracy reported by time servers on the internet is actually more detailed and more accurate than what is possible to be represented by the .NET date time format. So you can now go ahead and produce timestamps, for example, in this client using this corrected time, send your data to the server, and be sure that you can compare data and timestamps collected from different clients on the network. So this is a basic, this was a basic sample of how to use sockets on Windows Phone. And like I said, I will upload this to CodePlex in the next days, where you can download it and study it in with more time and in more detail. Okay, so let's continue with the last part I wanted to talk about, which is obstacles and problems, just for a few minutes. Developing with sockets is often a problem when it comes to debugging and testing, because often threading is involved. You have time-sensitive operations. You handle lots of data. And also the phone hardware behaves differently from the emulator. So you may run into problems when you are looking for errors and when you debug your code that it behaves differently, like when you don't step through your code with the debugger, for example. And this also makes testing more difficult because the same setups, async operations, threadings, and also the fact that we don't have any mocking possibilities on the Windows Phone make it difficult and force you into investing more effort to unit test your applications and components when you do socket programming. And this often also hinders manual testing because some features like multicast, for example, cannot be used on one machine if you have the server component running side by side with the emulator, for example. You will receive errors. And also debugging the device is kind of difficult because when the device is connected to the computer using the USB connection, the networking interface on the phone is switched to an Ethernet type. So if you want to test your networking and socket logic using certain networking interfaces, you can do that while the phone is connected to the computer. So you have kind of a chicken egg problem here, which you need to solve using tracing statements and things like that. These are all things and problems you may run into. And also, of course, we have platform-specific limitations. For example, we have very limited DNS name resolving. Name resolving is available, but DNS resolving on the phone, we have some of the server-specific features of sockets are missing on the phone, which makes it more complex sometimes to achieve what you want to achieve. So these all are things you have to live with and you have to work around with when you work with sockets on the phone. Some of these problems are solved in an open source library I have created, which is named PhoneSA Remote Control. This library uses TCP and UDP sockets and also multicast to transport sensor and touch input and text data from the phone to a remote server, for example, a .NET desktop application. And in this project, for example, I have worked around all these limitations of not being able to debug when the phone is connected to the PC and things like that. So if you're interested in more on the topic and if you want to learn with a more sophisticated example of socket programming, then you can go ahead and take a look at this library, for example. I have also another small demo that implements an instant messaging client with some explanatory diagrams on my blog that go into more detail about how the use of the socket async event arcs and sockets work, how the normal patterns work that you're supposed to use with sockets. And I also talk about the current performance problems that we unfortunately have on some phone models, in particular HTC models, which is really a bad thing because this makes it almost impossible to create real-time applications, networking applications on these phones. And I hope that HTC will provide firmware and driver updates for these models soon. Samsung already provided updates to fix a similar problem for their phones, so I think it should we can expect fixes for these in the future. But for now, you should take a look at that post to get an idea what you will be dealing with when users have HTC phones and you use sockets at the moment. Okay, unfortunately the time already is up. We could talk a lot more and about a lot more details, but since we're already at the end of the webinar, I want to go ahead and do a quick Q&A session. Please remember that you can contact me if you want, using my blog or Twitter, if you have additional questions, or if you want to see some article or some detail explained, you can also contact me, and I will try to answer your questions offline. I have one question here in my list that says, can more than one app open a connection to a network on the same port? No, that's not possible. The multiplexing with networking and network communications is done using ports. So if you intend to have multiple connections at the same time, you need to use separate ports for these separate connections and separate communication channels. Usually what you would do on the server side is that you would listen for incoming client connections that is bound to a certain port, and then you would forward these connections to other sockets that are not bound to that specific port. So that's the common pattern to distribute multiple connections to multiple ports on the same computer. Multiple connections to multiple sockets on the same computer. Okay, so that's the only question I have in my list here. Alex, if you want to say some closing words, I can also. Okay.
Yeah, thank you, Peter, but there are currently arriving some questions.
Okay.
And it will continue till 9:10, and if there are any questions left, they'll be answered by email personally. Thank you for the understanding. We'll try to do our best. Just sending you. I think you should be able to see them now.
Yes. I have a question here. Is it possible to communicate between apps on one device, like it is often done in Linux apps, or, for example? The problem with that is that there's no real multi-tasking on the phone. So there's no way of two applications running at the same time. So this also, of course, makes it impossible to communicate between local apps using sockets. Then we have a question from Gary that is, I was unable to figure out how to use the async CTP to do asynchronous calls with the sockets class. I have never tried that, but the async CTP, or the new async feature of the C# compiler and the Visual Basic compiler depends on the task class or similar implementations to do its work. And since a different mechanism is used, I believe that with the current implementation for sockets, it's not possible to use the async feature. Yeah, I don't think that's possible because there's no involved object that could be used by the async feature to do that. A follow-up question about the communication between local apps. This also is not possible with Mango. No, we have the option to do some sort of multitasking in the form of, for example, scheduled tasks that are executed periodically. But this does not mean that two applications are running at the same time. When the user navigates away from your application, it will be put into something called the dormant state, where it is not possible to do any to execute any code. It's like a thread that is frozen, so you won't be able to do that in Mango either. Then we have a question. Hi, I used the SDK multicast sample and created a Silverlight UI server like app. The Windows Phone device sends data which is parsed by the app. However, the data received by the Silverlight app is not correct. That's pretty difficult to answer by the information given. If you want, you can contact me and explain the problem in more detail, or even send me a sample project I can take a look at. and I will happily answer your question offline. You can also take a look at the open source library I've talked about that also uses multicast clients and server implementations to do multicast communication.
Okay.
Oh, okay. The
Is
third.
that all?
Yes, the third message also was about the multicast. Please really feel free to contact me so we can discuss the multicast problem offline. That's I would be glad if I can help you with the problem. Okay, so I hope I didn't miss any questions. That's all I have in my list.
All over, Peter.
Okay.
We hope to have you deliver more webinars for SilverlightShow in future.
Thank you.
Thanks everyone for attending. I invite you to fill our survey displayed right now, just after you exit the webinar. 3 of you will win Peter's latest book on getting prepared for the Windows Phone exam. The recording of this webinar, as well as all demos and slides, will be available to you emailed within the next 2 days. Again for attending, and have a good.
Okay. I only have static noise at the moment, but I also want to thank everybody for attending and hope to see you in a future webinar. Thanks.